Alright, so I want to talk right now about how to find where a function has a horizontal tangent line. So we're going to say, where does f of x equals x squared over x squared plus 5 have a horizontal tangent line? Alright, so we have to take a derivative. Now the question is, what do you do with your derivative after that? Okay, so let's get the derivative first, then we'll address what to do with it to find where the function has a horizontal tangent line. Alright, so derivative, this is a quotient, so I would recommend using the quotient rule, although you could solve this by saying, well, f of x could be rewritten as x squared times x squared plus 5 to the negative 1 power. So you could solve this using the product rule, because we have the product of two functions now, or you could solve it using the quotient rule. I'm probably going to solve it using the quotient rule. Maybe I'll solve it both ways just for the heck of it. So we could say f prime of x using the quotient rule is equal to the derivative of the top. So the derivative of x squared times the bottom function, x squared plus 5, minus the derivative of the bottom function, x squared plus 5, times the top function all over the bottom function squared. Now that bottom function is a binomial. Make sure to square the entire bottom function. Alright, so let's take these little derivatives. What's the derivative of x squared? Well, it's 2x. So we get 2x times x squared plus 5 minus, what's the derivative of x squared plus 5? Well, oddly enough, the derivative of x squared is the same thing as x squared plus 5. That makes perfectly good sense if you think about it, because those are both parabolas. This is a parabola with a vertex at 0, 0. This is a parabola with a vertex at 0, 5. They're going to have the exact same slopes everywhere because they're the exact same shape. This is just moved up 5 units. So 2x times x squared all over x squared plus 5. Let's do a little bit of simplification. Let's look at the numerator. So if we expand and then collect like terms, we will have, let's see, 2x cubed plus 2x, no, not plus 2x, plus 10x, minus 2x cubed. Well, that worked out nicely, because now we are just left with what? We have 2x cubed minus 2x cubed. It's left with 10x over x squared plus 5 squared. That wasn't so bad. Again, do note here, the only steps that were calculus were this step and that step. The two additional steps there are just purely algebra and arithmetic. Do you want to see how you solve it using the product rule? So what if we said f prime of x, well, let's give ourselves a little more room here. F prime of x, okay, the product rule says the derivative of your first function, the derivative of x squared times the second function, x squared plus 5 to the negative 1 power, plus the derivative of your second function, x squared plus 5 to the negative 1 power, times the first function, x squared. So what's the derivative of x squared? X squared, it's 2x. So we get 2x times x squared plus 5 to the negative 1 power plus what's the derivative of x squared plus 5 to the negative 1 power? Well, that's a chain rule proposition. The chain rule says that you have to take the derivative of the outside function. The outside function here is x raised to the negative 1 power. So we would bring the negative 1 out front. So negative 1, we'll just write as a negative sign. And then we evaluate, so we have, all right, so let me get back up a second. So we bring the negative 1 out front, and then we raise our function to the n minus 1 power. So n currently is negative 1, so negative 1 minus 1 is negative 2. But that's like the derivative of the outside function, just using the generalized power rule. But you evaluate the derivative of your outside function at your inside function. The inside function is x squared plus 5. But then you have to multiply by the derivative of your inside function. So what's the derivative of this inside function? It's just 2x. So we have to multiply by 2x. But then don't forget about that x squared up there that we were multiplying by already. So there is the derivative using the chain rule of x squared plus 5 raised to the negative 1 power. So now we're done with calculus. We just need to do some arithmetic here. We have all these negative exponents. We know we want to write our final solutions without negative exponents, so that's a good place to start. 2x over x squared plus 5 is how this plays out. Now this one plays out as, let's see, we have a negative 2 power, so it's x squared plus 5 squared. And on the numerator, we're going to have 2x cubed. And now what's the last thing to do? We want to combine this fraction. So what's the common denominator going to be? Well, we have x squared plus 5 squared over here. We have x plus 5 to the first power over here. So if we multiply both of these by x squared plus 5, we'll get our common denominator, which is x squared plus 5 squared. So we have, let's distribute here. That's x squared times 2x. That's 2x cubed. 5 times 2x is plus 10x over the common denominator of x squared plus 5 squared minus 2x cubed over x squared plus 5 squared. And I think you see we get the exact same answer. Because we have common denominators, we get 10x over x squared plus 5 squared. So we get the exact same answer, which is nice. Two different ways to solve. Got here and got here. Notice here we really only had one step with calculus, although I could have added another line here showing the breaking down the chain rule. I decided to do the chain rule all at one step. But again, significant algebra and arithmetic, whichever way you decide to go. So the chain rule or the product rule will get you the exact same answer. Now, those are our derivatives. Okay, f prime of x, both of those exactly the same. Now, what do you do with that derivative if we're trying to figure out where f of x has a horizontal tangent line? So what is it? What is the slope of a horizontal tangent line? The slope of a horizontal tangent line is 0. So we want to figure out where slope is 0. Now the question is, do we evaluate f prime of 0 or do we set f prime of x equal to 0? It's going to be the latter. If you're trying to figure out where the function has a specific slope, you set your derivative equal to that slope and solve for x. So in this case, we want to know where the function has a horizontal tangent line. So we, let's see here, we set f prime of x equal to 0 and solve. So here's f prime, so we say 10x over x squared plus 5 squared let's fix that 5. X squared plus 5 squared equals 0. Now, you have to think about this right here. All right, what is going on right here? We want this left-hand side to equal 0. And the question is, when does that left-hand side equal 0? All right, well, think about this denominator here. Okay, or just think about the entire fraction. How would we get this equal to 0? How would that end up being 0? I think the only way for that to end up being 0 is if the numerator is 0. Okay? Because think about what's going on in the bottom. We wouldn't want the bottom to be 0 because then we'd have division by 0 undefined. But if we have a 0 divided by something, that'll give us the 0 we're looking for. In fact, look at the denominator here. That's x squared plus 5 squared. What do we know about x squared? It's always at least 0. Whether you plug in a negative value for x or a positive value for x, x squared is always at least 0. 0 is the smallest it can be. It's non-negative. So if you say at the smallest this can be 0, it can never be negative, it's always going to be at least 0 plus 5 and squared. So the lowest this can be right here is 25. It never can be 0. So this left-hand side can only be 0 if the numerator is 0. So we can instead of solving this complicated equation, or seemingly complicated equation, we can just say 10x equals 0. When is that true? Because this is the only way for that entire left-hand side to equal 0. Well, that's easy to solve. X equals 0. So x equals 0 is where there is a horizontal tangent line. You know, it may turn out that sometimes you're left with a quadratic derivative, and so you have maybe 2 points where you get a horizontal tangent line, or lots of points where you get a horizontal tangent line. But here, we only get one solution. So at x equals 0, we have a horizontal tangent line. Okay? So there's only one horizontal tangent line, and that's it. Now, if we want to find the equation of that tangent line, well, we have to remember that the equation of a horizontal line is just y equals a, where a is the y-intercept. So if we want to figure out what the y-intercept is, well, we simply evaluate our original function at x equals 0 and see what the y value is. So what's our original function? So what is f of 0? Not f prime of 0. What's f of 0? Well, going up here, if you evaluate f of 0, you would have 0 squared over 5. 0 squared divided by 5 is still 0. So f of 0 is 0 in this case. So the equation of my horizontal tangent line is y equals 0. It occurs when x equals 0. Now, I think the way the question was worded in your homework, it just asked for the points where the function had a horizontal tangent line. It didn't actually ask for the equation of that horizontal tangent line, but here it is if you would like it. Now, let me contrast this conclusion here, this question, with another common question. Another very common question says this: find the slope of f of x at whatever value. Let's say at 1, at x equal 1. What is the equation of the tangent line at x equal 1? Notice how this question is different. The original question was, where does f of x have a tangent line? So you're a horizontal tangent line. So you're looking for a specific place where f of x exhibits a slope of 0 in this case. Horizontal tangent line, slope equals 0. You want to know where the slope equals 0. So you find the derivative and set your derivative function equal to 0, solve for x. Now, this question over here is different. It says, here's a specific x value. Find the tangent line equation at that specific x value. It's a related process, but is a different process. So here, we find the derivative, that's the same, but then we evaluate the derivative at our desired point. And here, in this case, slope at x equal 1. So going to your derivative function, what is f of 1? Well, 10 times 1 is 10. Divided by 1 squared is 1. So 1 plus 5, that's 6. 6 squared, that's 36. So our slope at 1 is 10 over 36. That is 5 over 18. Okay? Now, once we have our slope, excuse me, once we have our slope, then we can use the point slope form to find the equation of that line. Remember point slope form is y minus y1 equals m times x minus x1. But what do we need? We have x, that's our x1 specifically. We need a y1. So we need to find the corresponding y value when x equals 1. Because we have our slope. Slope is m, which is 5 over 18. Okay? So what's the corresponding y value here? So what's our point? It's 1 comma something. So let's go back to the original function to find the corresponding y value. So it'd be 1 squared, 1, divided by 1 squared plus 5. 1 squared, so 1 over 1 plus 5, that's 1 over 6. So here is the point in question. There is x1 and there's y1. So if I use the point slope form, I'll have y minus y1 equals m times x minus x1, like so. I'll just need to write this in slope-intercept form now. So y equals 5 over 18x minus 5 over 18 plus 1 over 6. Now let's combine those two constants. So we'll have y equals 5 over 18x. Now let's add these without, since we're out of room here. let's get a common denominator and add these. What's the common denominator? I think it's gonna be 18. So to get 18 right here, I need to multiply by 3 over 3. And in that case, I'll have 3 over 18 plus negative 5 over 18. So I think that ends up being negative 2 over 18. But what's negative 2 over 18? Oh, we do have a little more room, sorry. So you get negative 2 over 18, then you get y equals 5 over 18x minus 1 over 9. So there is the equation of the tangent line at x equal 1. Again, just to recap on the process, to find the equation line or to find the slope at a specific point, you evaluate f prime of that point. If you want to find where f exhibits a certain slope, in this case the slope we wanted was 0, you set f prime of x equal to that slope and solve for x. So those are two very similar processes that we're going to use throughout the next at least chapter 3 and chapter 4. So it's really important that you differentiate between those two processes. Okay? Know when to use this process, that is setting the derivative equal to 0 and solving, versus this process, which is evaluating f prime of a certain given x value. Okay? In this case, we took it even further, and we found the equation of the tangent line. I'll graph these and show you how they look graphically. So it's always important to visualize what all this information means. All right, guys. So here we are. This red curve right here, that red curve is the original function, x squared divided by x squared plus 5. It's right here, the blue, that blue line, which is in this case the same thing as the x-axis. That is the horizontal tangent line at the point 0, 0. Okay, so at the purple point, that is the origin. The blue line, which is on top of the horizontal axis, is our horizontal tangent line. That's the one we found originally. Now, looking over here, the second question that I just kind of made up was to find the equation of the tangent line at x equal 1. So here is the point x equals 1 comma f of 1. Okay, and the green line here is the tangent line at that point 1 comma f of 1. Okay, so there we are. Now, do notice that this is a kind of a weird tangent line in the sense that, look, it crosses over the red curve. It crosses over the red curve. That's because this tangent line actually occurs at something called an inflection point. And then when that happens in this specific case, the tangent line actually crosses over the curve. It still only intersects at one point in that small neighborhood around x equals 1, but the tangent line is not completely on one side of the function. So there we are. There is the red curve. There is the blue line is the horizontal tangent line at the point 0, 0. And the green line is the tangent line at the point 1 comma f of 1. I think it was 1 over 6. Yeah, it was 1 comma 1 over 6. Okay? All right, I hope that's been helpful. If you have any more questions, just let me know.